Ladies and gentlemen, welcome to C Sharp 101. For the continuation of our lesson, we're going to move on to lesson 7, and we're going to be talking about and looking at C Sharp expressions. Now, on the lesson overview here, the C Sharp language provides a complete set of language elements for writing expressions. What is an expression? Well, basically an expression is a set of language elements combined to perform a meaningful computation. Basically, in its simplest form, one example would be adding the value of 1 to a variable. This lesson here, we're going to demonstrate expressions created with each of the C Sharp's built-in operators. There basically are 4 types of operators. You have your urinary, binary, ternary, and then there's some others that don't fit into a category. What is that? What do those different categories mean? Urinary is basically singular, and it affects a single expression. Binary requires 2 expressions to produce a result. An example would be like A plus B. Then you have your ternary that has 3 expressions. They're a little more complicated, and we'll look at those later on in the lesson here. So we'll talk about these in order. So let's go ahead and start with the urinary, not urinary, but urinary. It's kind of a tough word to say. Urinary expression, or urinary operators. As I said before, urinary operators affect a single expression. The operators in this category include the plus sign, minus sign, the double plus sign, which is increment. Then you have the double minus sign, which is decrement. And then you have the exclamation point, which is a logical negation. And then you have the tilde, which is the key right next to the 1. If you guys aren't familiar with the tilde, it's a bitwise complement. So let's take a look at the plus operator here. Now, the plus operator has no effect on the expression it's used with. Wait a second. What? What do you mean no expression or no effect on it? Now, why would a language have an operator that has no effect? Well, basically, it's for consistency. Most C# operators have a logical complement. Since there is a minus, since there's the minus and that's its logical complement. The minus sign, its logical complement would be the plus operator there. So basically, they do it for consistency, just so you have it there. For the most part, this operator is available for explicitly documenting code. For example, what we have here below is we're just declaring some variables. Int negative equals -1, int positive equals 1. You have our int result, and our result equals plus negative, and our result equals plus positive. The plus sign will have no effect on the result variable, even though we put some type of operator in front of there. So let's go ahead and take a look at that and see exactly what I mean. Let's go ahead and go into our coding environment, whatever it may be. Hopefully it's, Visual Studio, whatever version you have. Could be 05, could be 2010, could be 2012, doesn't really matter. So here we go. We got some code defined here, and we're going to go ahead and uncomment this. And as you can see, we have pretty much basically what we have on the slide there, and just declaring some variables, and then we're using the plus operator there to change them or try to change them, which it won't actually happen. Then we're going to display the output here. So let's go ahead and do that. Why are there build errors? Oh, let's take a look here. Oh, I forgot to comment this part out here. It says later on in the lesson. Okay, there we go. Sorry about that. Alright, so basically we have our negative and we have our positive. Then we have our end result, which is our negative result. Then we have our P result, which would be our positive result. And even though we do the plus and the plus there, and we output the results, the value of them absolutely do not change at all. So the plus operator has 0 effect on us in the urinary form itself there. So like I said, basically it's just for the documentation there and whatnot. So let's go back to our slide here, and let's go on to the next one, which would be the minus operator. The minus operator here allows negation of a variable's value. In integer and decimal type, the result is the number subtracted from 0. For floating point types, the operator inverts the sign of the number. And then when a value is NaN or not a number, the result is still not a number. So let's go ahead and take a look at this. Let's hop back into our code. And we'll comment out the plus operator here, and we'll uncomment our minus operator here. Okay, so now we basically have the same thing. We have negative, positive, we have n result for a negative result, and we have our p result. Now this here, the values will actually change, and you'll see that. So what we have here is we have negative, positive, we have negative 1, and then 1. And then we have our end result. We set our end result equal to minus negative. And then we have our p result. We set that equal to minus positive. So as you can see, then we output the results for end result, and he becomes a positive 1. And then we do that to the positive number, and we output the result. He becomes a negative 1. So basically, it reverses. It almost looks like it reverses the signs there. But like I said before, the result is always subtracted from 0. So hopefully that kind of shows you a better understanding of that there for the minus operator. Let's go ahead and head back to our slide. Move on to the next one. Alright, the double plus sign increment operator. Now this is where we get into where we can actually see some things happening a little bit better, and maybe be able to grasp it a little better as well. So the increment operator allows you to increase or increment the value of a variable by 1. The timing of the effect of this operator depends upon which side of the expression it's on. Now, it's odd or interesting that they bring up the timing of the effect, because no matter what, you're not going to be able to do anything based on the timing, since it's all executed on the same line anyway. So even though some things are actually different, it doesn't, in my opinion, it doesn't really matter on how you do it or not. If you want to be consistent, I would pick one or the other, pick post or pre. So basically what we have here, we have post and pre-increment, and what that exactly is here, as you can see, we have a couple integer variables, and we have index set to 6, and then we set count equal to index plus plus. So what that happens there is at first it sets count equal to index, which index at this point in time here, I mean, it happens so quick. I mean, the count would be 6, and then it increments index, and then index is 7. But it happens so fast that your count is always going to end up being 7 anyway. It's never going to happen where it's going to be 6. So that's a post increment there, and then pre-increment is just the exact opposite. You put the plus plus in front of the actual variable there, so you have count equal plus plus index, and at that time there, both count and index are going to be 7. Like I said, the timing of it is really pretty much irrelevant. I've never run across an instance where post or pre, one of them was beneficial over the other. So I don't know. I guess there might be, but I don't know of any. And if you all do, you can certainly let me know. So let's go ahead and take a look at this in action. Hop into our code and let's comment that out again. So now we'll go to the increment operator. Okay, so what we got here, like I said again, we got a couple variables, increment, and we have a result. Both of them are integers, and we're going to display the result before increment. We're going to increment it, and then we're going to display the result after increment. So we know we have result. Result is equal to 0 right there, and then we set result equal to plus plus increment. Increment starts out at 0. We add 1 to it, and then result becomes 1. Like I said, the timing of it doesn't really matter. So that's the increment operator. So hop back to our slide, and let's look at the decrement operator, which is basically the exact opposite of increment. You're gonna subtract 1 from a variable's value, and again we still have the timings, which are involved post and pre. So we can go ahead and take a look at this as well. And let's see here. Uncomment that, or comment that out. Wrong way. Okay, decrement, like I said, basically the exact opposite. We'll run that again, and we got, we display our result before decrementing, which is going to be 0, and then we'll decrement the result by 1, and then we'll display the result after the decrement, and now we have -1. So pretty basic and straightforward there for increment and decrement. So let's hop back to the slide and we'll move on to the next one. Now this one's here, they they get a little they don't get a lot harder. They might just become a little more difficult maybe to grasp the concept of it. So basically, this one here is the exclamation point, and it's the logical complement operator. And this operator here serves to invert the result of a Boolean expression. Now, if I remember correctly, we've used this a little bit in the past in some of the previous lessons, in some of our if statements, where we know the value could be false, and we want to make sure that it's true when we execute our first set of statements. I'm not sure. However you want to do it there, but I think we've used it in the past. But basically, what it is, we have a Boolean variable here. We set it equal to true. We have another Boolean b result. We set that equal to exclamation point Boolean expression. That would become false. And then we set b result equal to exclamation point b result, and then that would be true. So let's switch to our code so we can actually take a look at this. And basically, like I said, it's just reversing the value of the Boolean expression. So if you are true and you throw an exclamation point in front of it, it's going to be false, and vice versa. So let's hop down here, go and comment this out. Uncomment that. Okay. So we have two Boolean variables, one called b result, one called n result. So our b result is set to true. We set that to true as we declare it there. And then we set our n result equal to exclamation point b result. So our n result should be false. And then we output that to the screen. And then we set our n result equal to the opposite of our n result, because we already know our n result should be false, and then our n result should flip back to being true. Let's take a look at that here. Pan up a little bit. Okay, so the value of b result is true, and the value of n result using exclamation point on b result, that value becomes false. Excuse me. Then we have the value of n result using exclamation point on n result itself. It was true. It was false, and then it flips back to true. So basically, it just reverses true and false on a Boolean type variable. And like I said again, in if statements, if you do like, if this is true and you want to look for a false, just throw on the exclamation point in there, and that'll reverse the value for you. So it's pretty easy to look at and demonstrate. Maybe not so easy to understand and grasp the concept of it until maybe you practice with it a little bit. Instead of using it, just seeing it in code like this. Like I said, you can try it out in like some if statements. Like, let me give you an example. Let's just type one out here real quick. Let's bust out of debug mode there. So let's go if b result, and this is basically going to say if b result is true. We're going to cancel that right line. B result is true. Oops. So let's go and run that. As we see right now, B result is true. Okay, because we have it set up here. Now, if we put the exclamation point in front of B result, now it's basically saying if B result is false, that statement no longer gets ran because B result is not false. B result is true. So since we're not setting it to something, it's not going to flip it around like we did before, because before we actually set a variable equal to the opposite of that variable's value. So since we're not doing that now, we're actually looking for it. So we're basically saying here on the if statement, if B result is false, which is not. So that this block of code here does not get executed. So that's basically where I use most of the exclamation point is in if statements, depending on what I'm looking for. I mean, obviously there are other areas that you use it in, but 80% of the time I'd probably say I used it in if statements here and whatnot. And it's easier to see how the exclamation point works when you do something like this, rather than just throwing it in a bunch of variables and displaying them out like that. So I'd probably go ahead and practice that if you don't quite understand that concept there. Just go ahead and mess around, make some nested if statements, and 3 or 4 Boolean variables and kind of play around with that, it probably take you 10-15 minutes to really get that down and understand that. Now the next one is a little more complex, and it's the bitwise complement operator. It's the tilde. This operator inverts the binary representation of an expression. Basically, all the 1s are turned to 0s, and all the 0s are turned to 1s. Now, you can't visually see this, so I've constructed a small program that will output the string value of an integer so we can see that the bits are actually changing. So let's go ahead and take a look at that program here, and we'll see how the bitwise operator actually functions. So let's just go and open it up here. Bit to string demo. Okay. Basically what we have here is we have a program that's going to ask the user here for a number. Since we want an 8-bit number, that's what we're working with, is 8 bits. We need a number that's less than 129. I believe that's right. It could be off, but anyway, I chose 128 because I'm very I'm very used to network bit math and things like that, and that's always for 128ths or something like that. I'm not sure why I chose that. That's just what I chose, so deal with it. So then the next thing we do is we get the results from the user, whatever they put in there, and then we display, say, hey, this is the number we're going to use, and then we show the string representation in the binary format. Then we flip it around, and you could basically say this is the reverse, the binary reverse. If you always don't want to say bitwise complement operator, because it's very long to say. So you just say this is the binary reverse of it. So we reverse the binary, and then we display it again. So let's go ahead and take a look here. And let's just go ahead and throw in, like, say, 15, for example. So the binary representation of 15 would be, if you're familiar with binary code, we all know that it goes 1, 2, 4, 8, 16, 32, 64, 128. So what we have here is we have 1, 2, 4, and 8, which equals 15. And as you can see, all the ones are zeros. So then what happens is then we flip it, and so then everything that was a 1 before now becomes a 0, and everything that was a 0 now becomes a 1, and you can see that right here. So now the number went from 15 went to 240. And we can go ahead and run that again on any number that we want. We can go ahead and we can type in like 128. So you can see 128 is the very last bit here, or the first bit, however you want to look at it. And so then it gets flipped, and everything gets, these are all zeros, and it gets flipped around, and everything here becomes 1. Honestly, I haven't used this a whole lot. Not saying that you won't, or that it won't come up, because there's definitely reasons for this. There's been a few applications that I've written that do use this, but just not very many. So I definitely learn it and be able to utilize it, so you know what's actually going on there. I can't think of an example right now that you would use it. I mean, if you're writing maybe a networking application to do subnetting and subnet masks, this would definitely work. So, if you're familiar with networking, the subnet mask is basically, I shouldn't say it's basically the reverse, but if you're familiar with how subnets and networks work, it uses the reverse of numbers for when bits are locked in, when bits are not locked in, and things like that. So I guess that'd be the only example I can think of right now. If you're writing some type of subnetting calculator, subnetting, application of sorts there, where this would come into play for sure. So that's the bitwise complement operator there. And see, the next one we're going to be looking at here. Let's see. Oh, that's all the urinary operators there. So the next section we're going to move on to is going to be binary operators. And binary operators, again, like I said, are operators that take at least 2 expressions to produce a result. All right, so with this particular lesson here, we're actually going to break it up into multiple videos. So we don't have one video that's 2.5 hours long, or an hour long, hour and a half, whatever it may be. so you don't have to sit down and just watch it all at once. I'm going to break it up into several different parts here. This first part here is the unary operators. The second part will be the binary, and then we'll do the ternary, and then we'll finish out with the operators that don't fit into any category there. So that's going to be the end of this first part. So if you like the video, go ahead and give it a thumbs up. If you want to see more of these, go ahead and click subscribe, and I'll have another video for you soon.